In this problem, we're told to find the following for path A in figure 3.54. A, the total distance traveled, and B, the magnitude and direction of the displacement from start to finish. We're also told that the various lines represent paths taken by different people walking the city, and that all blocks are 120 meters. And so I went ahead and drew the part that we're focusing on in this problem, which is going to be path A, right? And so let's just go ahead and start with the first part. So for the first part, what we're trying to find is the total distance traveled. And so when they say the total distance, they're basically talking about basically the length of the line that the person is going to walk. And so what we know about this problem is that each side of these blocks is going to be 120 meters. So what we're going to do is say this is 120 meters, right? This is going to be 120 meters. And what I'm talking about is these lengths right here. This is 120 meters. And then this side is going to be 120 meters. So if they want the total distance of the length added up, and so we're also not including the path. So keep in mind that this is just going to be a negligible distance. So what we want to do is add up the side of the lengths to go to get how far they're traveling, right? Because they're going to travel this 120 meters plus this 120 plus this 120 and then this 120, right? So if we want to add them up, we just do 120 plus 120 plus 120 plus 120, right? So basically the lengths of all the blocks, and they travel 4 blocks. So it's going to be all these added up, which is just going to be 480. And so this is going to be in meters, right? Because one block is in meters, right? So 480 meters, that's going to be the distance they travel. So now for B, it's going to be a little bit more complicated. So for B, we're trying to find the magnitude and direction of the displacement from start to finish. So the way you want to think about displacement is essentially the shortest distance between two objects. So this is where the start and end is. So in this case, this is the end and this is the beginning. So the displacement is basically going to be the shortest line, which if we draw it, we know that this line right here that I'm drawing is going to be shorter, right? So what we're trying to do is find the length of this line. But how do we do that? So the way you want to think about this is just like a triangle. So I'm actually going to just redraw this triangle, but down here. So we have this triangle, and what do we know about the lengths of the triangle? So we're trying to find this length. I'm going to refer to it as C. So what we want to find is C. And we need these lengths, right? But what do we know? So we know that this length is 120 meters. So we know one side of the triangle. And then we know that this length is going to be this side, right? 120 plus 120 plus 120. It's just going to be this length, right? All these added up, because that's going to be this length. So 120 plus 120 plus 120 is 360. So we know that this is going to be 360 meters. This is going to be 120. And what we're trying to do is find C. And if you have a right triangle like this, right? This is going to be a right triangle. What we can do is find the length C, right? By using the Pythagorean theorem, which basically tells us C squared plus A squared, or C squared is equal to A squared plus B squared. And so what C is, it's basically the hypotenuse of your triangle, which is what C is, what I said C was, right? And so A and B are just going to be the lengths of the other side. So this length is A, and we're going to call this B. So if we want to solve for C, what we can do is take the square root of both sides, right? So C is going to be equal to the square root of A squared plus B squared, right? And notice we have A and we have B, so we can just solve for C by plugging it in the formula. So C equals the square root of A squared, which we said was 360. So 360 squared plus B squared, which is just 120. So you want to just plug this in. So you do the square root of 360 squared plus, oh, I forgot the square. This is 120 squared, right? Because B is 120, so 120 squared. So make sure just plug this in. And so when you do this, you're going to get that it equals, or C is going to be equal to 379.47 and so on meters. I'm just going to round to the whole number. So I'm just going to say 379 meters to make it just a nice number. So 379 meters. Make sure you round how your teacher wants you to, though. So 379 meters, that's going to be the magnitude of the displacement. So now that we know the magnitude, what we want to find is the direction. And so when they say direction, essentially what they're talking about is this angle right here. So basically what we're trying to be doing is solving for this angle theta, because that's your direction. And so the way we're going to solve for it is by using trig. And so we know the tangent of an angle, right? So the trig function we're going to be using is tangent, and you'll see why in a second. But we know tangent is equal to opposite over adjacent, right? So that's tangent. So the opposite side of our angle is 120. So 120, and then the adjacent side is this side right here, which is 360, right? But keep in mind what we want is theta, not the tangent of theta. So if we take the arc tangent of both sides, what that's going to do is cancel the tangent. So you just have theta equals the arc tangent of 120 over 360. So essentially just your opposite over adjacent, right? And so what we want to do is just go ahead and plug this in. So you want to do the arc tangent of 120 divided by 360. And when you go ahead and do that, you're going to get 18.4349. So I'm just going to say 18.4, and then it's going to be in degrees. So 18.4 degrees. So it's going to be 18.4 degrees, but you want to specify exactly where that angle is going. So keep in mind, if we say that this is the y-axis, it's going to be 18.4 degrees to the right of it. So you would say 18.4 degrees to the right of the, and then keep in mind it's going to be the positive, right? Because it's upwards, so positive, I'm just doing a plus sign for positive y-axis. So this would be your answer, or the direction, right? So 18.4 degrees to the right of the positive y-axis, that's your direction. Your magnitude was 379, so these are going to be your answers to B. And then your answer to A was this right here, 480 meters. But yeah, so these are going to be your answers, and hopefully you found this useful.